Hey guys, good evening. Hope you all doing great. What did we do in the last class?
Good evening.
Good evening. We did implementation of a logistic. So this is a notebook I set to do an EDA. I don't know whether you have done or not. We are just left with how to evaluate a classification model that is a logistic. So let me explain different metrics used to evaluate a classification algorithms, like what is confusion matrix, accuracy, recall, precision, etc. Okay, so we'll be done with one regression and one classification algorithm. So from next week onwards, we'll discuss about different algorithms and whatever I discuss. So everything is applicable for regression as well as a classification. Only these two algorithms are like distinct. Linear regression can be used only for a continuous data. Logistic regression can be used only for a classification. Okay, when it comes to KNN, you can use it for both regression and classification. Same goes with decision tree, support vector, random forest, XGBoost, gradient boosting, and also ANN algorithm. Okay, so everything is applicable for both classification and regression, but the logic will be little bit of logic will be different. Otherwise, the process will be the same. Okay. So with these two algorithms, I have discussed all the possible data cleaning techniques. I hope everything is clear. The same approach has to be used whatever data set you pick. So probably in this weekend, I'll just frame certain problem statements and I'll put it for you as an assignment. Pick any data sets that you want and you can start working on it. Okay? Yeah. So I gave a notebook. All right. So first, let me discuss about our different metrics available in a classification. All right. So if you remember, when it comes to a linear regression, so how did you evaluate the model? What was the base there in order to evaluate a model?
Functions.
So basically, in linear regression, we used error.
Sorry, you just mentioned you will give us this assignment over the weekend. So will you upload on the same portal or do we have any other group?
You can upload on a same portal, or else you can even email me. I guess you have an upload option for assignments. Let me check just a minute. Hmm, it's not active. Maybe okay, I'll just enable it. I'll show how to upload. So no worries. Yeah.
Sure.
In linear regression, we used error to evaluate the model. So based on that error, we had a different metrics. So metrics used for evaluating regression are completely different. So we used mean absolute error, mean squared error, RMSE, mean absolute percentage error, and then we used R2 scope as well as adjusted R2 scope. So these are the metrics used to evaluate a regression model. So we call them like a regression metrics. Okay. It is applicable only for this. Like if you want to evaluate a classification model, we have a different technique. So now let's understand how to evaluate a classification model. Tell me, how do you evaluate? So there we were using actual minus predicted. So now how to evaluate classification model in a sense? As of now, we are using a logistic regression. Yes. How do we evaluate? How do you say the model predictions are correct?
Using accuracy, and there are others.
Okay.
Yeah, one of them was accuracy, if I can recall.
Mhm. Majorly, whenever you want to evaluate a classification model, it is basically predicting a categories, right? Like diabetic, non-diabetic, is there a high risk of heart attack or not? Something like that. So that means, don't you think the evaluation should be based on the correct predictions and the wrong predictions?
Yes,
So evaluations are based on correct predictions and wrong predictions. Or you can also call correct classifications or a wrong classifications. One and the same. Prediction, classification, one and the same. Okay, let's say for example, you have a data. Let's represent the actual data, okay? I'm calling Y as an actual. And how do you represent a predicted? We represent it like Y hat. So I'll just call it like a predicted. Okay. Let's say actual values are something like this: 0, 1, 1, 0, 1, 1, 0. Okay. And let's imagine the model predictions are, I'm just assuming, so 0, 1, 1, 1, 0, 0, 1. Okay. Yeah. So now, so how do you say prediction is correct? How do you say the prediction is wrong? If actual is 0, predicted is also 0, then it's a correct prediction. And what is 0 in terms of positive and negative? What is 1? Which one do we call it like positive? Which one do we call it like negative?
one is positive, I think, and zero is negative.
Okay, 0 is negative. Understand those. So 0 is negative and 1 is positive. Okay. So now, if predictions are the first case, okay, if actual values are 0 and your predicted value is also 0, is it a correct predictions? Your predictions are correct? Actual is
Yes,
also 0,
Yes.
predicted is also 0. I can call it like true. And what is 0? Negative, negative. So we call it like a true negative. Understood? If actual is also 0, if predicted is also 0, we call it like a true negative. Like that, we have a different naming. Only then I can derive the different metrics. Understand this? Next one. Let's say if actual is 1, the predicted is also 1. Mm.
True positive.
Yes, it's true, and 1 is nothing but a positive. 1 is nothing but positive. So I'll call it like true positive. Okay, next one. Let's say actual is 0 and your predicted is 1.
False positive.
Yeah. So false. It's actually wrong, predicting wrong. So I call it like a false. And what is it predicting? 1. 1 is nothing but a positive. So we call it like a false positive. Hope you are getting. Next one. If actual is 1 and your model predicted it like a 0.
False negative.
False. And it's predicting 0. 0 in the sense it's negative.
I used to confuse a lot on this true positive and this one. But by this way, it's a great way to explain. Thank you.
Yeah. Understood. If you understand this, then the next process becomes easy. Without understanding this, like you will confuse. Clear, guys? 0, 0, true negative, 1, 1, true positive. If it's making wrong, false, and false positive or negative is decided on what we predicted. Okay? All right. So now, based on this, in this, can you tell me the correct classification and the wrong classifications? How do you represent current classification according to about thing?
True negative, true positive, both are correct classification, right?
Yes. Yes. Correct classification in the sense true negative because 0 getting classified as a 0 and true positive 1 getting classified as a 1. Okay, and similarly, classification prediction 1 and the same. So wrong classification, opposite. So false negative and false positive, basically called as a wrong classifications. Okay, all right. So now, so we have a different metrics. Already I said it in the last class. So in that, the very first metric is going to be the confusion matrix. The entire the metrics related to classification is derived based on this confusion matrix. Like name, if you don't understand, definitely it will confuse. So these, whatever I discussed today is like super important. Most of the people couldn't answer it. I've seen many with very good year of experience, done PhDs, but still couldn't justify why they use accuracy, why they use recall precision and all. Okay, it's not mugging up a formula, it's about understanding in which scenario we use which metric. Okay, that makes you a data scientist, not just implementing things or not just remembering things. Okay, so when I see confusion matrix, what is the definition of a confusion matrix? So basically, confusion matrix, what it will do, it creates a matrix. Okay, it creates, matrix in the sense different rows and columns will be there. It creates a matrix which includes correct classifications and misclassifications. Correct classification and misclassifications. Okay. So now deriving confusion matrix will become easy for you because you have already understood what is true negative, true positive, false positive, and all. So now, how confusion matrix look like? When I see confusion matrix, I'm taking actual values. Okay, I'll take actual like a here I'll take actual, Here I'll take predictor. So usually we will have two values now, 0 and 1. Okay, actual values are 0, 1, predicted values are also 0, 1. So what confusion matrix will do? It gives a matrix like this. And now it's gonna fill it with correct predictions and wrong predictions. So now tell me, if actual is 0, predicted is 0, what will be the value?
True negative.
Yes, this is true negative. Then, if actual is 0, predicted is 1,
False positive.
it's wrong, so it's a false. Predicting 1, so it's a positive. Good. Here. Actual 1, predicted 0.
False negative.
So it's a false and it's predicting 0, so it will be false negative. Then, actual 1, predicted 1.
True positive.
So it's a true positive. This is a confusion matrix. Any questions? Is everything clear so far? Understood the matrix? Same way, in the place of true negative, false negative, true positive, basically you will get a values. Okay, all good? Shall I proceed to the next one? The second matrix is accuracy. You know what is accuracy?
No.
Okay. Accuracy is simple. It's a ratio of correct predictions out of all the predictions. Okay, accuracy is all about it's a ratio of of correct predictions out of all the predictions. And you people know how to represent a correct predictions, right? How do you represent a correct predictions? Use confusion matrix here. What do you mean by correct predictions? How do you represent?
TNTP.
Hmm. All predictions in the sense? So your formula becomes accuracy equals true positive plus true negative because they are the correct predictions. 0 classified like a 0, 1 classified like a 1. All predictions in the sense true positive, true negative, false positive, and false negative. Okay, this is the formula which is used to find the accuracy. And when accuracy is not valid, a very important thing. So you should be a little cautious. Accuracy is not valid when data is imbalanced. Accuracy is not a valid metric when data is imbalanced. I had discussed about a balanced, imbalanced data in the last class.
Just give me 1 minute, please. A review. I was not able to attend yesterday. Else, I will go through the lecture.
Okay. Simple understanding. Let's say classification means like two classes will be there now. Like if same number of observations you have related to both the categories, we call it like a balanced. Like if it's a diabetic data, 100 observations related to diabetic, 100 observations related to non-diabetic. It's a balanced.
Okay.
If it's imbalanced, one of them will have 1,000 observations, other one will have 300 observations.
Mhm.
It's imbalanced.
So same applies for multi-class as well.
Yeah.
Okay, thank you.
And also I showed you how to balance it as well using the smoke. You can refer to it. Well, this is
Uh,
all related to accuracy. So it's not a valid metric when data is imbalanced. When number of classes, observations or samples in classes is not the same, accuracy is not a valid metric. Clear guys? Understood? Let's say for example, if accuracy is like zero point 0.8, so we could say that it's 80% better model. Okay. If you get on evaluating your model, accuracy equals zero point 0.8, you could say that 80% of the predictions are right. 80% of predictions are correct. This is how accuracy will work. So now, as I said, when it's not balanced or imbalanced, usually accuracy is not a best metric, right? So for that, we have two more, actually three more. So one of them is third one. I'll just call it as precision. Most of them confuse with this precision and a recall. Be little cautious of this. Understand carefully. If not, make sure you ask me to repeat. So we call it like a precision or a precision score, even for above one, accuracy or accuracy score. What is precision? Precision is simple. Out of all the positive predictions, how many are actually positive? Understand? Out of all the positive predictions, how many are positive? Can you guess the formula? The table looks like this. Tell me which are the positive predictions. Bit tricky, understand.
Starting with TN and TP. These are the positive predictions.
Positive predictions should be positive. Should be one. So I can say this is a positive predictions.
Okay, then it will not be true or false. Before you were asking true positive, I think.
No, I asked the same thing. Positive predictions.
Ah, okay, okay. I misunderstood.
Positive predictions in the sense the predictions made should be positive.
Okay.
Your model should have done a positive predictions. It should have predicted it like a 1.
Okay.
Getting, even if actual is 0, your predicted will be 1. If actual is 1, the predicted will be 1. This is positive predictions. This is false positive, and this is true positive. Understanding? So the formula will be, out of all the positive predictions, we got to know that positive predictions are false positive and a true positive. Among all the positive prediction, among false positives and the true positives, how many are actually positive? What do you mean by actually positive?
True positive.
Yes, that's the formula.
Can you please write above as well how many are actual positive?
Oh, I wrote this like a positive. How many are positive? Anyways, okay. You're confused with actual positive. It should be how many are, you don't compare this actual. It's how many are actually are positive. Getting,
Yes, yes,
or I'll see like how many are true positives. This makes sense.
yes,
Guys, clear? See, also in another simple way, you can take it like an example of non-diabetic and a diabetic. Non-diabetic, we represent it with a 0. Diabetic, we represent it with a 1. Okay, so what happens? Among all non-diabetic patients and a diabetic patients, okay, so we consider positive predictions. Positive predictions in the sense, whatever predictions your model has done related to non-diabetic patient and a diabetic patient should be diabetic. If model is predicting it like a diabetic, for both the cases, we call it like a positive predictions. Okay, out of all the positive predictions, how many are actually true positive? That means how many diabetic patients correctly classified like a diabetic? Making sense now?
yes,
Understand like this. You have a diabetic and non-diabetic patients, so your model makes up predictions. Positive predictions in the sense model predicting diabetic patient as a diabetic, non-diabetic patient as a non-diabetic. In that, how many diabetic patient classified like a diabetic will be a precision score. With these combinations, how many are actually a diabetic? Okay, next one. Coming to recall. Hope you are getting third has done now fourth. You can take pass fail example as well and you can derive it. It's all about understanding. One or two times try to understand it, you'll get it. Don't mug up, you'll forget. You remember like this. If you mug up, you can't remember. Recall. So just opposite. Out
out
of
of
all
out of
actual,
all negative out of all negative predictions, how many are true negative, right?
not related to positive, we take it for actuals now. Out of all actual positives, how many are positives? Out of, in a reverse way, out of all,
Okay, denominator will be numerator, numerator will be denominator.
out of all actual positives. Now we are thinking about actual positives. Out of all actual positives, how many are How many are what? Again, same. True positives.
Now this is confusing.
Okay, I'll
We are
show.
okay.
You need to understand with this table, otherwise it will be difficult. Understand definition with this table. You always stick on to this table. Only then you can understand things. So this is predicted, now, and this is actual. Okay, tell me. This is true, negative, true, positive, false, negative. So can you tell me actual positives?
FN and
TP. This no. This is actual positives. Getting
No.
actual positive in the sense actual value is one. Understood? Actual value, that means the patient is diabetic.
Okay.
Person has a diabetic. Now, whatever prediction your model does, so you have a actual positive they are saying now.
Mm-hmm.
When I say actual positive is diabetic here, the person has a diabetic, symptoms confirmed. So now your model what it will do? It makes two predictions. One can be diabetic, another one can be non-diabetic. Getting? Diabetic in the sense it's a true positive. Diabetic, non-diabetic in the sense it's a false negative. Understood?
Okay.
This is actual positives. Among actual diabetic patients, how many diabetic patients classified as a diabetic? Compare both top and bottom. Same thing, you can see the diagnosis like how it has changed. Okay, making sense?
Yes.
So, formula will be how many are true positive out of actual positives. So, false negative and true positive. That's it. Actual positives in the sense among all the diabetic patients, how many diabetic patients classified like a diabetic? Because there are two possibilities. Your model can predict it like diabetic patient as diabetic, and also there is a chance that diabetic patient can be predicted like a non-diabetic. So among all diabetic patients, among all actual positives, how many are truly positive? Getting?
So actual positive is different than positive. Can you
Yeah.
scroll up, please?
That's the reason I didn't give actual in a previous case.
Yeah, I just
See,
want to review.
here, among
Just
all
scroll
the
up
positive predictors,
a bit more, please. Yeah, here. So out of all positive,
predictions,
hmm, okay,
how many are true positives?
okay, no makes sense. Okay,
See, I'll give one more definition.
don't confuse, otherwise we'll forget this.
No, in terms of diabetic, I'll give. Um, Let me see. Out of all, positive predictions means what? Out of all diabetic predictions, how many were actually, or How many were diabetic? Understanding? Out of all the diabetic predictions made by your model, how many were diabetic? Okay. Out of all diabetic predictions, I'm speaking. All the predictions your model has done that, okay, a person is diabetic, how many were diabetic? Coming to recall, among all diabetic patients, how many predicted it like a diabetic? Among all diabetic patients, that means actuals. Among all diabetic patients, how many are predicted as diabetic?
Scroll up, please. Out of all diabetic predictions.
Made by your
If
model.
we are focusing on predictions. Okay, it's
P for
correct.
predictions.
Yeah, yeah.
Precision, P for predictions. Recall for actuals. So I gave prediction first. P for predictions. Out of all the diabetic predictions made by model, how many were diabetic? Already diabetic patients. Understood now?
Okay.
Remember like this. First, remember this table. If you remember this table, deriving them is easy. If you remember the formula, you will end up saying nothing in interview. Many do this mistake. I've seen. First question I remember whenever I take interviews is this itself. Many failed. I have tested.
Hopefully, we will also fail.
Yeah. No, you have understood now.
I was just kidding.
Yeah. Guys, you understood what is recall, what is precision. Now tell me, among false positive and a false negative, which is dangerous? I'll speak that later. Let me finish the F1 score. You finish this. Let me finish F1 and then I'll come to the importance. And you just go through this once and then I'll teach that. Otherwise, it will go above your head. The final one, fifth one, F1 score. So, what is F1 score? F1 score, in the sense, it's an harmonic mean between precision and recall. Usually, when you have to consider both precision and recall are important, you can go with that. Recall will give you F1 score, and the formula is
So for both precision and recall, when we will use when data is balanced or
when data is imbalanced, these things can be used, but there is a specific use case. I'll tell after this when to use what. Recall plus precision. So these are the five important metrics we use to evaluate F and score. Sorry, used to evaluate a classification model. So important thing used when both recall and precision are important. So that means when false positive, false negative are both are important. Okay, when false positive and false negative both are important, in that case you have to use a FN score. Just go through this so far, whatever I did. Any questions, ask me, and then I'll discuss about.
So I
Oh,
have a question here.
hmm.
How we will know when recall is important and when precision is important?
That's what I said. I'll explain.
Okay.
You just go through like whatever I said so far. If everything is understood, we'll proceed. I'll explain. When recall is important, that is important. That's what I said at initial also. Without understanding that, you fail to answer it. Just go through it once. Just check. I'll share a link. Is it accessible? I didn't directly. I don't know whether I can export or not.
Yes, it's accessible.
Okay. All good. Shall I explain when to use what?
Yes, please.
Okay. So first question, tell me, which is more dangerous, false positive or a false negative?
I think false positive.
Okay. Others? Okay. So first case, let's take a medical domain. Okay. Let's say you are doing project related to medical domain. Let's say simple one. Yeah. We have two categories. One is a cancer. We represent it with one. No cancer or non-cancerous. We represent it like a zero. Okay. In the scenario, so if someone has a cancer and doctor says like, yeah, you have a cancer, no worries, correct predictions. If no cancer, if the doctor says like no cancer, all good. Let's say if somebody has a cancer and doctor says like no cancer, and somebody don't have a cancer but doctor says you have a cancer, which case is more dangerous in this case? So which is false positive, which is false negative in this?
First one is false negative, the second one is false positive.
Now tell me which scenario is more dangerous.
First,
False positive?
Mm-hmm.
false negative is more dangerous.
Okay, understand the situation. Okay, good. Somebody has a cancer and doctor says like no cancer. Usually being a human, what is human mentality? When somebody says like no, people are happy. We don't even go for a second opinion. Very rare that people would go to a second opinion. At that moment or for that particular day, they would enjoy that they don't have that disease. And it's a cancer situation, and you know, in a cancer, if we neglect, what will happen? If patient is assuming that okay, you don't have a cancer, and if you don't go to a second opinion, and if it's not taking treatment, and it's a cancerous cells, don't you think it will double and the situation becomes like worsen? Yeah.
Yes.
So when it's a medical, false negative is always a dangerous. Okay. In this case, no cancer. A person doesn't have a cancer. If doctor sees like a cancer, at that moment, so definitely the patient becomes a panic. So he'll become cautious of his health. He'll go to a second opinion. And the second opinion, the doctors confirms that, okay, no cancer. Only panic was there, no health risk or like, no life risk. But in first case, very dangerous. There is a possibility that increase in cells would lead to a death as well. Right? When it's a medical domain, you should always focus on reducing false negatives. So reducing false negative in the sense, so what should be considered? Reduce false negatives in medical domain. So what should be taken care here? False negative should be reduced. That is like classifying positive class as a negative class should be reduced. So usually coming to a metric among recall and a precision, which focus more on a false negative. Look into the formulas. Precision focus on false positive, recall focus on false negative. Understanding what should be used when medical domain. Use recall. Why we use a recall? You know the recall formula. True positive, false negative plus true positive. Out of all the what actual positives, how many are correctly classified? That's what we are looking for. How many cancer patients classified like a cancer? So if any cancer patient classified like a non-cancer patient, so such mass classification has to be reduced. If you reduce this, the score will increase. Okay, you should consider a recall whenever you think of medical domain. Understood? Is it making sense now? Yeah. Next one. When it comes to a business, or I'll take another example like a email classification. Second example, I'm taking email classification. When I say email classification, let's say you have an email that needs to be classified like a good email. We call it like a ham, and there will be a spam. Okay. So tell me, if good email is classified like a spam, if spam email classified like a ham, which is more dangerous?
What is the question? First one is or
Ham means like a good email.
good email. Okay.
Hmm.
Second one is
So what is this? False negative, huh? False positive. Zero one, false positive.
First one,
Mhm. Second one is a false negative.
this one.
Mhm. Which one now? You people said wrong.
first one is
False
more
negative.
important, right?
Okay, let's say you got a good email. Okay, let's say for example, you are being selected for a next round of interview, and you have an interview scheduled at 1 p.m. Okay, if it sits in a spam box, usually what happens? Usually we have an habit of looking into an inbox, right? We rarely look into a spam box. We miss a good opportunity, right?
Yes.
And what if spam gets classified like a harm? Good message. Or if somebody sent a message like you have won $1 million lottery, something like that, we get to know that okay, it's a spam, and we just put into a spam. So nothing to lose there. And this is like we are missing an opportunity. In this case, the false positive should be taken care. In that case, you have to use a precision. Okay, so here false positives should be reduced. False
So we
positive.
should have some domain knowledge like when to use precision, when to use record, right?
Exactly. You need to have an understanding of categories. Usually for medical domain, false negatives. For business domains, usually we consider precision. Because precision formula is false positive plus true positive. This should be reduced. Understood, guys? Any questions? Any questions? This is all about usage. Like when both false positive, false negative. In some scenarios, like both should be considered. In that case, you can just go with a FN score. But usually, if we evaluate all these metrics, when you write a final conclusion, so you should decide like which metric should be used, like which can be used to validate your model. Clear? Shall we implement? So open a Google Colab. I shared you at the start of a class. Upload data. It's available in the same notebook. If you don't have notebook with you, you can just create a copy of my notebook and you can just implement it. Again, we spent almost like 1 hour in understanding all these things, but implementation happens in just like 5 minutes. Okay. So again, same thing. You have to import the libraries. So from sklearn.metrics, import confusion matrix, recall score, precision score. What else you have? Accuracy score, and then you have FN score. Okay, and then you can call accuracy score first confusion matrix. You pass your whitelist as well as your white grid. So you got a confusion matrix. Accuracy score whitest white grid, 85% better model. Recall score whitest white grid, 83. Then we have a precision score. In our case, it's in heart attack risk classification. It's good to go with our recall score because it's medical domain precision. Like classifying, the people who have a less chance of heart attack as a you have a heart attack. Still okay, nothing to lose. Anyhow, they will be little conscious of their health. FN score, white as white. But here it's just like 83% of them. 83% of the high chance of heart attack people has been classified like an heart attack. Okay. Remaining misclassified. Similarly, if it's score balancing. Well, this is how you gonna implement different classification models.
So in linear regression, we are our goal was to reduce the error. Okay,
Hmm.
here with these values, what we have to do, like 85.
Goal is to reduce the misclassification.
So this mean 85% are classified accurately.
85% C is not positive class classified like a positive, negative class classified like a negative.
So procedure
Remaining
is giving us a good, right?
Sorry?
Precision is 90%. So this is the good one for this or what?
85 is good only. Precision, what is happening here? See, my problem statement is related to predicting like whether person will have a heart attack or not.
Okay.
Okay. Heart attack risk in the sense like one. Less risk is zero. So now understand. High risk one, low risk zero. Okay. So coming to a recall, among all the positive predictions, that means among all the predictions that model has done related to high heart attack risk people, how many really have that symptoms? It says only 83%. Remaining it's doing wrong classifications.
Okay.
Coming to precision. So here what is happening? Just opposite. Among all the high risk people, how many actually predicted like high risk?
Okay.
Getting?
Okay. Got
So
it.
it's 90%. High risk one because it's actual positives. So two scenario we have. How many high risk predicted like a low risk? And how many high risk predicted like a high risk? So your precision says that 90% of the high risk people have been predicted like a high risk. And remaining 10% it has done like this. Okay, here we consider 83 because false negative has to be reduced. The opposite case, among high risk patients and low risk patients, how many are actually predicted like a high risk? This is positives, no? It should be, sorry, this should be precision. Precision, among all positive predictions, how many are correctly classified as a true positives? Getting understand in terms of 1 0. So which is false positive, which is false negative? This is false negative, right? And this is false positive because it's a precision. In recall, we are trying to reduce this case. High risk people classifying like a low risk. This has to be reduced. If this is reduced, this will increase. In this case, low risk patients predicted like a high risk, but still manageable, no? This precision because anyhow, low risk people classified like high risk in the sense they'll be little cautious of their health and they become aware of like how to be and how to control that in the future. Clear?
Okay.
Yeah. So there is one more. AUC and ROC curves. Still, you have a patience to learn. we have one last metric, AOC, ROC. Anyways, let me discuss that with the KNN. Okay, I'll discuss in our next class. So this is just like evaluating your model at different thresholds. Usually, Logistic will evaluate your model at a zero point 0.5 threshold, but here what will happen, it will try to evaluate at different thresholds. And then I'll discuss what is Keenan algorithm, how it works, and also let's do the implementation. Once Keenan is done, we'll start with decision tree based algorithms. So again, like understanding theory and just implementing the models, no pre-processing and all, because already known to you. Okay. Yeah.
Okay.
All right then. That's it for today. Thank you. Thanks for joining. So please
Thank you.
practice all these stuff.
Thank you.
Okay, thank you.
Thank you. Good night.
Thank you. Bye.
Bye bye.